Thank you very much for the introduction. Artificial intelligence is increasingly taking over our everyday jobs to make our life easier. Some of these examples include autonomous cars, robots, wearable health, and assistive devices. All these applications that you're looking, they require for a lot of data processing and knowledge extraction in real time. On the other hand, there is a new trend for new class of computing which require smaller, higher energy efficiency with much more higher computational capability for these devices. So back in a couple of decades ago, we had these gigantic mainframe computers that were taking the space of the room, and they were consuming hundreds of thousands of watts. And nowadays, we have all these wearable smart devices that, by the way, they do a lot more computation than that gigantic mainframe computers, but they require a lot less power consumption. So the new constraint is to have much lower power consumption within a lot smaller devices, however, with much higher computational capability. So I give you one example. So the headset that you're seeing there, I'm wearing, it's basically is a headset that has been developed in my lab and can be used for disabled people to control their environments, including driving their wheelchairs. So the AI processor that is behind the headset is responsible to perform all the data processing, knowledge extraction, machine learning, and AI to basically make that application working. However, in order to have that headset being able to be wearable, and at most we want to charge this one once daily, so we need to have that AI processor in the back to be very low power consuming. So for example, for this application, we don't want to have this more than 100 milliwatts. On the other hand, we don't want to have any data being sending out because, again, to save the power, so the memory that's on the processor is required to be very limited, much smaller than you see it on the computer, so it's only 1.6 megabit. So together, all these are requirements with the real-time requirements of getting this wheelchair driving. So it's a lot of challenge to put everything crunched to this headset processor. So in my lab, me and my team are excited to develop the next generation of the low-power and programmable and scalable software and hardware processing engines that can be used for a variety of these machine learning applications. So some of these applications are spanning from biomedical, autonomous systems, assistive devices, stress and behavior monitoring, and even environments, for example, for air pollution monitoring. So I give one example here. So one of the projects that we are leading is for brain signal processing in order to measure the human cognitive state and basically their focus and the stress, and eventually use these brain signals to control the environments. So again, this is a wearable device, and it's basically require a lot of processing and also very low power consumption. And for example, for this example, we are looking at the user perform basically the commands for this particular application every half second. However, there is another application that, again, my other team of students looking at is with much more higher computation capability, which is for driving autonomous drones. So these devices, they require to perform a lot of computations within 30 milliseconds, doing the images and frame per second with very limited power. So the AI processor that we are developing is basically responsible to address all these different applications requirements. And we recently built a new chip, and an AI accelerator chip, which is basically tiny enough that you can fit it in a quarter coin and still is addressing all these processing application requirements. And we are looking at basically the device being fit in one of the headsets that I showed to you to basically perform one of the brain applications that we are looking. And at the end, I would like to thank my team, all different generations, that they basically have done so much work on these exciting projects and making all these exciting projects moving forward and coming up with better solutions. Thank you.